What is the most powerful thing in the universe? It's a question older than science itself. From the moment we first looked up at the night sky, we've wondered what drives the stars, what fuels creation, and what invisible hands hold reality together. Power. The very word stirs something within us, a sense of awe, of scale, of something beyond our reach. Here on Earth, we measure power in explosions, engines, and storms. But in the vastness of the cosmos, those things are nothing more than flickers of dust. Out there, power takes on a new meaning, not just strength, but the ability to shape the universe itself. It's found in the blinding light of newborn stars, in the silence of black holes, in the fury of cosmic collisions, and even in the quiet expansion of space-time. In this journey, we will explore the greatest forces ever known, from the smallest spark to the birth of everything that exists. And perhaps, by the end, we'll discover that the most powerful thing in the universe is something we never expected. To find the most powerful thing, we must first understand what power means beyond human terms. On our planet, power is measured in watts, in force, in destruction. A nuclear explosion releases more energy in a fraction of a second than entire cities consume in a lifetime. Yet the sun releases billions of times more, every second, without effort. The scale of cosmic power defies comprehension. Energy can appear in many forms: gravity, radiation, motion, even the very structure of space and time. And these forms of energy shape everything, from the movement of galaxies to the beating of a human heart. Every second, the universe converts matter into light, light into motion, and motion back into gravity's endless dance. Each transformation a reminder that power is not just destruction, it is also creation. For every dying star, there is one being born. For every collapse, there is expansion. The universe does not waste its energy, it transforms it. And among these transformations, some stand far above all others. Stars are the beating hearts of galaxies, colossal nuclear furnaces scattered across the void. They are born from clouds of dust and gas, drawn together by gravity until their cores ignite in fusion. In that moment, a star becomes alive, releasing light that can travel for billions of years. Our Sun is one such star, modest, steady, reliable. Every second, it converts 600 million tons of hydrogen into helium. That fusion releases enough energy to illuminate our world and sustain every living thing upon it. And yet, compared to the titans of the cosmos, our Sun is little more than a candle. Consider Scuti, a red hypergiant so vast that if it replaced our Sun, its outer layers would stretch beyond Jupiter. Or our 136A1, one of the most massive and luminous stars known, shining millions of times brighter than our Sun. Its surface burns at 50,000 degrees Celsius, unleashing light and heat that could vaporize entire worlds. But even the greatest stars do not burn forever. As they age, they swell, fuse heavier elements, and finally collapse under their own gravity. And when that happens, the universe witnesses one of its most spectacular displays of power, the supernova. A supernova explosion is the death cry of a giant star, releasing more energy in a single instant than our Sun will produce in 10 billion years. The shockwave tears through space, spreading heavy elements, carbon, oxygen, iron, the building blocks of life itself. From that destruction, new stars are born, new worlds take shape, and the cycle continues. Every atom in your body, every breath, every heartbeat, was once forged in the heart of a dying star. Power, in the universe, is not only about might. It's about transformation. And the stars are its first great teachers. But beyond the death of stars lies something far stranger, a place where power defies understanding. When a massive star collapses completely, it can form a black hole, a region where gravity becomes infinite. No light escapes. No sound, no matter, no hope. A black hole is not an object in the traditional sense. It is a distortion in the very fabric of space-time, a place where all the rules break down. At its center lies the singularity, a point of infinite density where physics, as we know it, simply stops. These entities come in many forms. Some, called stellar black holes, are born from collapsing stars, only a few kilometers across but with the mass of several suns. Others, supermassive black holes, lurk in the centers of galaxies, millions, or even billions of times heavier than the Sun. At the heart of our own Milky Way lies Sagittarius A star, a monster 4 million times the Sun's mass. And beyond, in the distant reaches of the cosmos, lies TON 618, one of the largest ever discovered. Its event horizon spans billions of kilometers, large enough to engulf our entire solar system. And yet, black holes are not just destroyers, they are creators. As matter spirals toward them, it forms a disk of gas and plasma so hot it glows brighter than all the stars around it. From these disks, powerful jets of energy erupt, shooting thousands of light-years into space. These jets, born from the edge of nothingness, can ignite star formation and reshape entire galaxies. The paradox of black holes is that within their darkness lies light, a brilliance born from their hunger. Gravity, in its most extreme form, becomes a generator of cosmic creation. In a universe ruled by motion, black holes are the ultimate stillness. And yet, their stillness radiates unimaginable power. When a supermassive black hole consumes matter at a furious rate, it becomes something even more extraordinary, a quasar. Quasars are among the brightest objects in the universe, burning with the light of 1 trillion suns. They are ancient, formed in the early universe when galaxies were still young and chaotic. One such quasar, known as 3C273, is so luminous that it can be seen from billions of light-years away. Its light began its journey before our planet even existed, and yet, through a telescope, we can still see it today. When one of those jets from a quasar points directly at Earth, it becomes a blazer, a cosmic spotlight piercing through the darkness. Its radiation floods across space, carrying the energy of unimaginable violence. Quasars and blazers are the engines of creation's edge, powered by gravity and fueled by chaos. They shape the galaxies that orbit them, regulating the growth of stars and the balance of cosmic structure. Here, power is not random. It is order through destruction. The black hole consumes, the quasar shines, and the universe evolves. But to understand true power, we must look deeper, far beneath the scale of stars and galaxies, into the fabric of the universe itself. Everything that happens, from the fall of an apple to the collision of galaxies, is governed by 4 fundamental forces. First, gravity, the gentle but persistent pull that binds planets, stars, and galaxies together. Second, electromagnetism, the force of light, electricity, and magnetism, shaping the visible world. Third, the weak nuclear force, responsible for radioactive decay, for the transformation of particles, for the heat of stars. And finally, the strong nuclear force, the mightiest of them all. The strong force binds the very core of atoms, holding protons and neutrons together. Without it, matter itself would disintegrate. When unleashed, it releases energy on a scale beyond imagination. It is the source of both stellar fusion and nuclear fire. In these forces, we find the foundations of reality. They are the laws that govern everything we see, from the glow of a candle to the birth of a galaxy. They are the universe's hidden framework, invisible, yet absolute. And still, beyond these forces, lies something deeper still. 13.8 billion years ago, everything we know, every star, every planet, every atom, was compressed into a single point. A singularity of infinite density and unimaginable energy. And then, in an instant, it happened. The universe was born. The Big Bang was not an explosion in space. It was the expansion of space. A burst of pure creation, where time, matter, and energy erupted from nothingness. In less than a fraction of a second, the universe expanded faster than the speed of light. Temperatures soared beyond comprehension. Matter and antimatter collided in a storm of creation and annihilation. And from that chaos, the first particles emerged. As the universe cooled, those particles formed atoms, hydrogen, helium, and traces of lithium. Gravity pulled them together, forming the first stars, the first galaxies, and eventually, everything we see today. The Big Bang is the ultimate expression of power, not destruction, but genesis. It is the origin of all things, the moment that gave birth to reality itself. Every photon of light, every atom of air, every cell of life, all of it traces back to that singular event. The Big Bang is not just the most powerful thing that ever happened. It is the reason anything can happen. For most of history, we believed that gravity would one day slow the universe's expansion. But then, we discovered something unexpected: the opposite was true. The universe isn't slowing down. It's speeding up. Something unseen is pushing galaxies apart faster and faster. A mysterious, invisible force known as dark energy. Dark energy makes up nearly 70% of the cosmos. Yet we do not know what it is. It doesn't emit light, doesn't interact with matter, and cannot be directly detected. But its effects are undeniable. Space itself is stretching, driven by this silent power. Some scientists believe dark energy is the energy of the vacuum itself, the natural tendency of space to expand. Others think it may be a new, undiscovered field, woven into the fabric of the universe. Whatever it is, dark energy may determine the fate of everything. In billions of years, galaxies will drift so far apart that their light will never reach each other. Stars will fade, black holes will evaporate, and even matter itself may decay. The universe could end, not with a bang, but with a whisper, stretched into a cold, eternal silence. Dark energy is the quiet ruler of all things, invisible, relentless, and absolute. And so, after all this, what truly is the most powerful thing in the universe? Is it the crushing gravity of a black hole? The blinding light of a quasar? The energy of the Big Bang? Or the unseen hand of dark energy itself? Perhaps it is none of these. Perhaps the most powerful thing in the universe is the mind that seeks to understand it. From a small world orbiting an average star, a species arose, curious, fragile, and full of wonder. We built tools to see the invisible, equations to describe the infinite, and dreams to explore the unknown. With thought alone, we have reached across billions of light years. The power of the human mind is not measured in energy or mass, but in imagination, in the ability to ask why. Every discovery we've made began with a question. Every theory, every telescope, every probe, all born from our need to know what lies beyond. In that sense, we share something with the universe itself, a desire to expand, to evolve, to understand. The universe creates through energy, we create through curiosity. Both are acts of power. So perhaps the greatest force of all is not a cosmic explosion or a black hole's pull. It is awareness, the ability of the universe to look back upon itself, through our eyes. The story of power is the story of existence itself. From the first light of the Big Bang, to the last fading glow of dying stars, power shapes everything. It builds, destroys, and rebuilds again, endlessly, beautifully, without purpose and yet full of meaning. We are part of that power, born from the ashes of ancient stars, bound by the same forces that move galaxies. And though our lives are fleeting, our curiosity endures. The universe will continue long after we are gone. Stars will burn, fade, and die. Galaxies will drift apart into darkness. But somewhere, perhaps on another world, another mind will look up and wonder, what is the most powerful thing in the universe?